Okay, here I am in the studio that I've created in an unused room. Room hasn't been used for 25 years in my house. Okay, because for various reasons we don't want to be on campus too much. I could do this from my office, and in some cases I might, but just trying to stay with guidelines, distancing, and so forth. I'm going to be doing most of the work, I think, from here. Okay, now here's a typical Blackboard, and I just show you this for the sake of seeing if you find it legible, if you can read everything. Sometimes down in this corner, up in that corner can get hard to see. Worked a lot on the lighting, so a little feedback on that is welcome. This incidentally is stuff that should be familiar from an analysis or pre-calculus course. Just using some basic functions, the 1 over x squared function, the basic exponential function, basic quadratic function, and relabeling axes. And we're going to do some of this in this course because this is very fundamental to the study of functions. And I mentioned study of functions. That's one of the chapters in the book that's addressed at a level well below that I would expect from a STEM-oriented student who's qualified for this course. Now the text material is still there, but it's material that you almost certainly know if you've just even had Algebra 1 and Algebra 2. And that's the basic prerequisite. If you've had analysis and pre-calculus, that's even better. But you'll be fine if you've just done really solid work in Algebra 1 and Algebra 2. Okay, because this course actually, the basic Math 154 course was originally designed for people who just had a good Algebra 1 course. Don't even need Algebra 2. It actually teaches a little bit of algebra in the course. We're extending it a little bit though, and we're going into the study of functions and modeling by functions. Okay, so you don't need to know this, you don't need to read it, just look and see if it's legible. Now, I've got a number of Blackboards and see how they're used. So I've got this up here just in case I want to write something. And maybe I will write a little bit, just so you see what that looks like. Okay, topics in this course. Sets. Now I think that your curriculum, especially in middle school, does stuff with sets, and your algebra courses will do sets. You get solution sets to equations and so forth. And I think most people have seen unions and intersections and so forth, but your textbook explains all that really well. So if you don't understand it, you're going to, and there'll be an assignment, and there'll be an assignment in the first day on sets, excuse me. Allergy season. And you notice that I cough away from the camera if I cough, just in case in the remote case that I have the COVID-19 virus, I don't want to spread it to you. Okay, so I don't cough in the direction of the camera. Okay, so anyhow, you got sets. And set theory is the basis of all mathematics. So we'll see a little bit of that, and we'll see maybe a little bit about how that works. You got to get a little deeper into mathematics to really understand it, but set theory is really foundational, and you don't see much of that in a course that's on the Algebra 1, Algebra 2, pre-calculus or analysis, calculus, differential equations, multivariable calculus. In that sequence, you don't see it. It's extraordinarily important. So everybody needs a decent foundation in sets, set theory. We have logic, formal logic. How do we test an argument to see if it's valid? What does logical validity mean? Okay, and logic is the basis for all computer science. Set theory and logic are the basis for all of computer science. So if you happen to go into computer science, and nobody at this stage really knows where they're going to end up, you need to know about sets and logic. That's all foundational. There's number theory. Prime numbers. How do you use prime numbers? Well, I assume that you know how to do greatest common factors and least common multiples using primes. Although there's sections in the book, it's relatively easy. It's fairly easy to understand. Number theory goes much deeper than that, to the deepest unsolved question in all of mathematics, which is the Riemann hypothesis. $1 million if you can solve it. People have been trying since 1860. Nobody even knows if anybody's close. Very interesting stuff. Now we're not going to get to the Riemann hypothesis. You've got to develop the whole theory of complex variables. And you know, am I doing this? Am I recording? Yeah, I hope I am. Okay, good. I want to make sure that I'm stepping around a lot of stuff here. It's easy to get distracted. Okay, number theory. So we start with primes and we talk about various aspects of number theory to get your feet wet with a little bit of number theory. We get into Goldbach's conjecture, Mersenne primes. None of these things are hard to understand, but they're extraordinarily hard to prove. And of course, we're not going to prove most of them. We will prove that there are infinitely many primes. Hopefully you've seen that proof. But if you haven't, it's pretty interesting and not particularly difficult to understand. Okay, sets, logic, number theory. We might study numeration, number systems, different bases, and so forth. But that's all pretty easy and straightforward. Excuse me. And also, this room hadn't been used in 25 years except to dump stuff in. And I was afraid to dust because of what I might raise. Now, I think maybe that's affecting me here a little bit too. Okay, so we have number theory. Okay, we have numeration, maybe numeration, but one thing we want to do is mathematical systems. Now it's a long way from the mathematical systems that we're going to see here to the mathematical systems that particle physicists use to try to explain everything in the universe. But one important mathematical system, extraordinarily important type of mathematical system, is a mathematical group. We're going to understand what that is at a very basic level. There's a very simple symmetry group, S3, and you can cut out an equilateral triangle and totally understand that group by moving rotating the triangle and flipping it and stuff in a way that you'll see. Mathematical systems. Okay, there's another group that has a similar name to S3. It's SU3. Well, that's a group of special unitary matrices. You don't know linear algebra. You don't know what unitary matrices are. You don't know complex variables. You don't know the functions of a complex variable. You don't know how special unitary matrix 3 works. But it's the theory of quarks and gluons. Okay, it's all in terms of that mathematical system. And that's a very interesting thing. But mathematical systems are not confined to particle physics. They're all over the place. In almost every field you find groups and a need to understand groups. So we're going to understand some of that. Now this is all mathematics that you don't get in standard curriculum. And if you end up in a field where you're going to learn about these things, it's going to be very helpful to you to have been exposed to it. Also, it just helps you think. Okay, we have the general topic of problem solving. How do you approach an unfamiliar problem? Because most of the mathematics that you've learned up to now is just you imitate what you've seen. You recognize that this is something I've seen, I know what to do because I've been told what to do, I imitate it, and I don't do anything really that creative. Now in a good geometry class, but there aren't many good geometry classes anymore, it's all been shunted down to middle school, and it's hard to do a good geometry class with somebody of age 12 or 13. You do get into good problem solving in a real Euclidean geometry class. Most people haven't had that experience, at least not very deeply. It's not confined to Euclidean geometry. It's in every aspect of mathematics, all of these and everything else. Okay. Now, another real important topic is functions. And mathematical modeling. Got a lot of mathematical modeling going on around the coronavirus epidemic that we're suffering from right now. And the mathematical modeling guides policy decisions. The mathematical models are actually fairly simple. The only problem with the mathematical models we have is we don't have enough information about how the virus behaves. Well, you don't just mathematically model viruses, you mathematically model things in almost every field. Any field you go into, mathematical modeling has an important application. Almost any field. So these are kind of the things that we're going to look at. And on a daily basis, we're going to have sort of a grid. And I've got a grid all filled out. It looks something like this. I never do go far enough, do I? Okay. So, I've got day 1, day 2, day 3, day 4, day 5. I've got, let's say, first day, and this is actually probably fairly realistic, and I'm writing kind of small here, so tell me if you can't read it, but it's not real important right now. It says sets and logic. And FNS stands for functions. Pound sign TH stands for number theory. And wild card stands for wild card. So if my plan for the day is to do sets, logic, functions, number theory, and wild card. Now we're not going to do all of it, but we're going to do some topics and sets, some topics and logic, topics and functions, number theory, wild card. Probably on the first day, it's going to consist of looking at some videos, reading the text, working some problems, and getting them to me in a certain time frame. Okay? Now that's 5 topics. We've got 5 hours of class, although we run from 9 to 3:30. That's 6.5 hours. There's an hour and a half of breaks during the class. So it's like we have 5 classes, and we have a fifth of an hour and a half of breaks. A fifth of 90 is 19, is 18. So we have like 18-minute breaks, and we'll see how we deal with that. But we're going to run it like there are maybe 7 or 8 different separate classes that extend through most of the 2 weeks of governor school, where we'll do maybe these topics the first day, and then we don't do sets again till the 3rd day. Instead of sets, maybe we do mathematical systems for a day. And we fill in this grid in a way that covers each topic in about 4, 5, or 6 sessions, spread out over the 2 weeks. This is much better than trying to do this. Now again, you might not be able to read down here, so I'm going to just do Well, let's go a second day. Sets all day the first day. Logic all day the next day. It's not going to work. Now, it might actually work because you've probably encountered a lot of the stuff on sets, maybe not so much on logic. But for most topics, this isn't going to work because if you do this, you do, say, a section of the chapter on sets. On the third day, you do another section of the chapter on sets. Okay? And by the time you do this, what you've done here has sunk in and you understand it. So that you're building on something you understand rather than extending yourself too far into the theory of sets when you still haven't processed what you've done on your first encounter. Okay? So we can't build like this. You get overwhelmed. At some stage in here, most people are going to find that they're not understanding what they see. Maybe they're fine for the first 3 days, pretty much okay for the fourth and the fifth, or the first section, first 3 sections, pretty much okay. Sort of okay, a little shaky in the fourth section. What the heck is that fifth section talking about? No, you do this one day, you do it a couple days later, you do another section a couple days later, and so forth, until you've processed it, everything is sunk in, and you've got really good understanding. Okay, so that's kind of the concept that I'm going with in the course. Now, for the approach we're going to use on the first day, it's probably going to be watch a video, do some work, and make sure you're getting set up so you can get into the system, so you get into the Canvas, which isn't going to be used all that much, but most of the assignments will be posted on Canvas once everybody gets on board and up to speed with using it, which is very easy to do once you've run through all the procedures. And the procedure simply, once you've got your EMPL ID, you go to the VHCC homepage, you click on My VHCC, and you get to the login page, and it tells you what to do from there. Once you've logged in, you see a big old grid of tiles. One of them says Canvas. You go to that one. Okay? Okay, well, more about that tomorrow. But that's kind of where we are right now, and that's kind of what we're looking at. So hopefully this has made a little bit of sense to you. You're not responsible for knowing this, but you might want to know it. You'll see it tomorrow.